All right, so my name is Marcus Ogle. I'm the Associate Director here at GCOOS. A little bit about me. I graduated from Texas A&M in oceanography 2012, and I went and worked for Bugro for 10 years, and then I went and hung out with this guy, Shell, for 3 years, and then I joined GCOOS last February. So I'm here, I'm excited. I'm excited about this panel. I think I know it too well, and we're gonna kind of jump into what we're doing. So the title of this panel is just industry partner updates. So our industry partners, as I said, we have Shell and Chevron here this morning to talk about this. Next slide, Shell.
Yeah.
So you can keep going next.
Yeah.
So the NTL, the Notice to Lessees, is essentially a Bessie and Boehm requirement that started out in early 2000s to require ADCP measurements or current measuring devices from any MODU or anything operating in the Gulf of Mexico at the time, now Gulf of America, to essentially collect ocean current data from the near the surface down to approximately 1,000 meters. So if you're operating an oil and gas platform, a MODU, a drill ship, a TLP, anything oil and gas that's actively producing or actually attached to the seafloor, you have to be collecting ADCP measurements. And this data needs to be transmitted at least every 12 hours to, at the time, NDVC website. Well, in 2021, after a server, after a server flood at the NDVC, GCOOS took over the management of the NTL data. This was planned, but it was planned for July of 2021, but it had to be moved forward, and we officially took over in April 2021. So GCOOS now houses all the NTL data, so all the data collected from these oil and gas providers. Next slide. There it is. So Jorge already touched on this NTL portal. It's ntl.gcoos.org. This is where all this data comes in. It's a really nice website. Mr. Philemon Guyano over here has spent a significant amount of effort and time with his team at HRI, bringing this up to date, having these now nice pages for every single provider. And like I said, there's of the 2 that we have here today, there's over 40 actual providers that are actually providing NTL data into GCOOS. Next slide. The biggest thing to point out here, that's funny, that the number of data points. So we have 49 active platforms with 94 inactive platforms. So we have essentially 150 roughly actual data points from different platforms in the Gulf of America. So some of these platforms may become offline and come back online. They might move out of the Gulf and then come back in. So those are the inactive ones. The active ones are ones that are actively sending data today, right now. And of that, we have yesterday was 730 million data points. We're up to 731 million data points and 13 million water temperature data points. So that's a lot of data just from this NTL portal alone. Next slide. So this again is busted in 2 sections. Session 1, Dr. Sergio and Dr. Mike from Shell and Chevron. And this afternoon section will be Mr. Ben Williams, Keith Curtis, and Dr. Rafael Ramos following on. So we're going to jump into session 1, and I'm going to hand it over to Sergio.
Thank you, Marcus. Right, so my name you see there. I'm a physical oceanographer. I've been working for Shell for the past 13 years. Before that, I was during a brief time with Bugro, probably like a year or so. Before that, I was with the University of Hawaii, and then before that, University of Florida. Can we do the next? So I like to call it Shell's Gulf Coast Surveying System. On and off, we have about 9 permanent platforms and 3 or 4 modules that are instrumented in the Gulf. You can see the different locations over here in the screen. So we cover pretty much the central Gulf of Mexico, or what we call the Mississippi Canyon. We have some here in Stones, which is a metocean buoy. We have Ogle, Perdido, and Whale in the Western Gulf. And Sparta here in the middle is scheduled to be installed next year. All of our platforms are instrumented with ADCPs, measuring the currents from the surface to about 1,000 meters. And in addition to that, we have wave measurements, air gap sensors, LiDAR, and med stations in most of them. So we try to keep it all standardized. For the Stones buoy is a full buoy that we have there. It collects wind, waves, meteorological parameters, surface currents, salinity temperature, and same currents through the water column. Now, in addition to that, we often deploy a near bed ADCP there, self-contained, most of the time because we are close to the 6B escarpment where we have bottom intensified currents. So trying to understand those a little bit better. So we have deployed that for a number of years now, but that's self-contained and it's not transmitted to GCOOS. Can we go to the next one? So here's basically the instrumentation that is in each one of our platforms. For the fixed platforms that you have there, we have ADCPs, horizontal ADCPs, the MIROs measuring directional waves, the RS Aqua sensors that can measure omnidirectional waves. But the main purpose is to check on the draft of the platform, right? We have the WaveX in some of the platforms, LiDARs measuring the wind profile in most of them, and the meteorological stations. The Stones FPSO, we have the buoy, which has the instrumentation that you see there, the aqueduct at the surface at a signature 55 to measure about 900 to 1,000 meters. Waves, etc., and the other DSPs. For the models, the mobile offshore drilling units, all of them are instrumented with usually just with an ADCP. And those come in and out of contract for Shell, but more or less permanently, we have 3 to 4 operating in the Gulf, reporting data to us. And all the data that reports to GCOOS is the ADCP and the horizontal ADCPs. All the other data we keep in-house. All right. So for the next slide, I was asked the question of why we collect this data. So I made here a list of the main operations that we relate to. So for us, the main purpose is to advise operations and design. So for operations, we have what we call weather window analysis, where we try to tell them in advance which times of the year or with certain probabilities associated, depending on your operation, how is the likelihood that you're going to have downtime or uptime. So this is pretty essential for planning and logistics. Now, when you're actually doing the operation, we use these measurement systems to try to understand what is going to happen, what is happening at the moment, obviously, and what may happen in the following days, hours, or days. For that, we rely on numerical models. So essentially, the value of the observations in this case, not only from us, but from GCOOS, is to try for us to understand how the models are behaving in case we need to look at that forecast, which is something that we most definitely do. For engineering and design, for the design of the facilities and the rest of the infrastructure, including pipelines, we use historical measurements combined with models to come up with the design parameters. What is your 100-year wave, 100-year current, wind, etc. Same with the profile. For the ADCPs, we use them in a variety of operations, including fatigue analysis. We want to know what is the fatigue life of risers, also for the riser design. So that's one of the critical pieces for us in being able to measure the water column. Now we are limited to the 1,000 meters, and one of our goals is to try to complete that water column. Because a lot of our platforms are much deeper than 1,000 meters. But NTL only requires the 1,000 meters, so that's on us to try to come up with a solution and that transmit also in real time. So I'm going to go through some of this because I know I was sitting in the back, you can barely read it. So I'm just going to read it here. So for operational support, you have weather window analysis. For offshore activity, real-time decision support. For drilling, marine, and construction operations. For engineering and design, the ocean design criteria for facilities and infrastructure, riser, that I was talking to you, and fatigue analysis. For marine and subsea operations, we also use the data that we collect and that GCOOS collect actually for route planning of vessel and offshore campaigns, and pipeline and seabed survey support. So pipeline, and I might say this is one of the biggest gaps that we have is for pipeline, because there's very, very little near bed current measurements available to anybody. I mean, I still use latex data collected, I don't know, how many years ago, Steve, how many years ago was it? 1992, I still use it to verify molds. And a lot of those didn't capture any hurricanes passing over them. So have to make up for that with molds, which, as we all know, are not the best, near the seabed at least. Right? For safety and emergency response, we have the storms, drift, loss of station, of containments, of oil spills. So we might use that to inform, so we don't have to. For life extension studies is another piece of the puzzle. So a lot of our assets are old, and when we need to extend the life of these assets because the fields are still producing, we have to justify the extension to the federal authorities, to BSEE, to the Coast Guard, etc. So that's a critical use of the in situ instrumentation for us because it allows us to compare the original design criteria with what actually has happened during the past 15, 10, 20 years to the platform, and then improve on that design criteria or determine that it was effectively designed to specs. And finally, regulatory and compliance for the government. I think those are the main ones, but we often find cases that we are using these data sets for other stuff that comes up, like visibility studies recently. You lower an ROV and you cannot see what, and they want to see what's going on there. So we lower an ADCP, we put it in the seabed and try to correlate the backscatter intensity with the visibility and the direction and strength of the currents. So observations to us are critical and are the best that we have. Again, the models are flawed a lot of the times, so our reality and ground truth is always going to be the measurements. So now, let's go to the next one. So I was asked a very difficult question here is to try to put a value to GCOOS data, right? It's hard to put a dollar value to it. It oscillates, it fluctuates. Some of it is maybe there might be some legal ramifications of it, but I believe that the biggest advantage of the GCOOS and the IUs is to give you a spatial view of what is going on. Right? We have dedicated measurements by point, but we want to know what happens upstream, downstream from us, and for that, it's very useful to have data from other platforms on other buoys or other systems. Also, if we are stepping into an area where we have not had any experience before, but there happen to be some data point from GCOOS, it's going to save us a lot of time and effort in the collection of the data. I'll give you an example. If you are working near the Magnolia platform and we don't have anything there, we can use that data for our design criteria, right? Because it's free and it's available. So that is a huge benefit. Some of the providers here might attest to this, is putting a mooring in the water for a year is on the order of $1 to $1.5 million. So that's immediate savings for anybody that's doing this, right? But the other part of it is safety and risk reduction, where I see that there's a lot of value in GCOOS. And I try to put here, reduce the uncertainty in offshore operations, improve the confidence in weather windows and environmental limits, extend situational awareness beyond the instrumented assets, which was talking about the spatial distribution of the and also improves the alignment between everybody, regulators, other operators. Often we are working in tandem at one location and we are all impacted by the same loop current eddy that is going on or the same storm, tropical or winter storm. So to have that spatial distribution is really very, very useful. And I think you guys probably are going to make this available later to the people. Yeah. So you can read this later at your leisure, but just to finish, like I would like to see more people using the data that we collect. We go to a lot of pain to collect this data, and our partners and third parties, the food growers, the RPS, the Woodstock groups, they go to a lot of pain to collect good data for us. We spend a lot of time in QC and transmission of the data. It's not that easy to transmit the data in real time. So I would like to see more people using actually this data and making good use of it. We use it already. We are happy with it, but it would be great if more people in the marine community uses it. I think that's all I have for now.
Well, thank you, Sergio. We'll hold any questions until the discussion after this, but next slide. Up next, we'll have Dr. Mike Yang from Chevron. Thank you.
All right, so good morning, everyone. So I think we're the only thing between you and lunch, so try to make it quick. So yeah, my name is Mike Yang. I'm a metallurgy engineer with Chevron. So I first want to thank GCOOS for the opportunity for me to be here and present an overview of Chevron's interest in the Gulf and also the different types of data we collect and why we think GCOOS is playing a very important role in facilitating the data sharing that is benefiting Chevron, but also benefiting the broader industry. Next slide. Okay, so this is I guess a similar map that Sergio just showed. It's just showing Chevron's interest in the Gulf. All the leases that we're holding. As you might know that Chevron is one of the largest leaseholders in the Gulf, and also all the producing assets that we have. Some of them are operated by us, and some of them are operated by our partners like Shell. So as you can see, we our footprint spans across a pretty large area in the Gulf. And also many of those assets just happen to be in an area that is very likely to be affected by loop current. I think we talked about loop current, from the previous presenters, but loop current is one of the major operational hazard that we have in the Gulf. It's essentially, basically a current system that can generate very high current speeds. We're talking about 3 knots, 4 knots, or even higher currents. So it's a big challenge for a lot of the offshore operations that we have. So it's very important for us to be able to, collect data, understand the loop current, where the loop current front is, how high the current speeds are, and be able to have the ability to predict the behaviors of the loop current. Yeah, next slide. Yes, I'm going to talk a little bit about instruments. So many of my bullet points are pretty similar to Sergio's. So obviously we have ADCPs on all of our permanent platforms and also our mobile drilling units, which is a better requirement. So the ADCPs, it really give us a very good view of not just the currents at the surface, but also across the water column, to give us a kind of a holistic view of what's happening with the water, the current system in different depth. So in addition to ADCP, we also actually have a unique system, kind of a one of a kind, called SKINS. So it's a surface current imaging system. It's actually a camera system. We have a pilot unit that has been deployed on one of our deepwater platforms, Bigfoot, since 2019. And it's like I said, it's a camera system. So it's a camera that's hooked up to just a regular computer, and the camera essentially just take pictures of the ocean surface waves, and it's able to kind of back calculate the underlying currents. It's very affordable. It's camera plus a PC, so all the components are you can purchase off the shelf. And it's also very no maintenance because everything is above the water, so it's very minimum maintenance effort. So far we've been pretty happy with the system. It was a system that was developed under a Deep Star program, and also the data from this skin system is also sent to GCOOS for sharing, so everybody can access it and have a look at it. And also one of the unique things about this system is that it actually fills a very important gap in our current monitoring in the Gulf. Because we talked about ADCPs, but ADCPs they all deployed underwater, and usually the first beam that they are able to collect data is probably around 20 to 30 meters. So we're actually missing the very critical range from the surface to about 20 meters. So this skin system really kind of fills in the gap because it's measuring the current right at the surface. And a lot of times, in a loop current system, you can have very sheared profile where the current speeds at the surface can be quite a bit different from at 20 meters. So in addition to ADCPs and skins, we also sometimes, whenever we have kind of important offshore campaigns, we also mobilize other assets like deploying drifters, and also sometimes we'll mobilize survey vessels, and also we've used a rocket aircraft system to basically collect more data to be able to give us kind of a better view of what the loop current is like, just kind of the overall kind of basin scale view of the loop current system. And also occasionally we have shared some of those kind of Chevron proprietary data with GCOOS to support different industry initiatives such as GCOOS. Next slide, please. So, so why the data is important? I think Sergio talked about it, and I think I alluded to it too. Is that loop current and associated eddies is one of the biggest operational hazard for us in the Gulf. So it's really critical for us to be able to have the ability to understand, what, the loop current, where the eddy fronts are, what are the current speeds. So the data from GCOOS is very important for us to have that understanding because, we're contributing data obviously from Chevron's platform, but we're getting data from all the other operators. Okay, I'll repeat. But we're getting data from all the other operators' platforms, so it really gives us a very, much bigger view of, the loop current system, and it's really important for a lot of the different activities we have, exploration, drilling, and also installation and other offshore activities. And we not only use the data to support operational activities, we also, basically the data that GCOOS collect, also we include that into our kind of database that we rely on for developing design and operating criteria. So it's really also important for kind of the long-term, criteria and statistics that we develop for our facilities in the Gulf. And also the GCOOS data also feed into the numerical models that we use to kind of develop our skill to forecast the loop current system. Because, obviously understanding, the real time, where the loop current is important, but a lot of times the questions that we get asked is, hey, can you tell us, where the loop current will be in a week, 2 weeks, what the current speeds will be? And even sometimes I got questions from our BU partners asking, hey, can you tell us if we're going to have loop current in a year at this specific location? And it's a good question, and I really appreciate their planning for it. But I don't have a good answer. So a lot of times for those type of questions, the only thing we can do is just kind of go back to historical average, like, hey, statistically over the past 20 years, this is the probability that you might see loop current at this site. But so I think that's probably one of the one of the gaps in terms of kind of being able to forecast loop current in the long term. But okay, next slide. Yeah, so data sharing. So like I said, we really think that GCOOS, the data sharing through GCOOS is very important for us and also for the broader industry. From several different perspectives. First from kind of operational perspective, it really helps us understand the current system and be able to forecast it and be able to reduce the weather downtime that's associated with the loop current encounters. And also from a safety perspective, I think Sergio talked about it too, is that it helps us improve our safety and reduce operational risk. Because a lot of times when the currents are so high, it's it can potentially cause obviously weather delay, but also sometimes incidents that can be very expensive. And also like I mentioned earlier, all the data, high quality data that GCOOS is putting together can feed into our fundamental database that we rely on for developing long-term statistics and design criteria for our facilities, floating facilities, but also the associated systems like the mooring systems, risers, subsea equipment. So it can help us, develop robust design criteria and help us kind of avoid having to, maybe in a couple of years, in a few years, after, having to kind of revise the criteria that we previously developed, which also can be very expensive. So, just to kind of summarize, we really value the partnership with GCOOS, and we think GCOOS is really playing a very important role, and the data that GCOOS is hosting and distributing is really kind of helping us improve our decision making for our operations in the Gulf, and not just for operations, but really kind of across the life cycle of a project, from all the way from early design phase all the way to long-term operations. So with that, I guess if you have any questions, feel free to ask Sergio.
A question?
There's a question.
I don't know if you can hear me without the mic.
I can hear you.
What we'll do is we'll have you say it and then we'll repeat it.
Okay. I'm Garrett Kuska. I'm the director of the Mid-Atlantic region, but I'm here more in my capacity as chair of the ICE Association. So working together with others like Deborah and Kristen and Jorge, who sit on the XCOM, we work with the office and others to try to keep us moving in the right direction, let's just say. So your comments about getting more folks, let's just say, to use the data is one that resonates well with us, because we're constantly looking for opportunities to get more value, right? Measure once, get lots of value multiple times. But we're also limited as to where and how to do this. So what do you think are some of the main challenges facing? You may know this, or you may have an opinion, but I welcome others to say as well. Do you think it's because people don't know about the data, or do you think it could be because we're not very good at translating these data into things that people use? Where ought we be starting? And I'm not picking on GCOOS, I'm picking on all of us, because we all face this problem around the country and trying to get more value out of a growing amount of data. And we're really appreciative for what industry does. And we'd like to get more value and have more, not just the private sector, but others as well, using those data to make decisions to help the economy and so forth.
Oh, thank you. I think that's a good question. And should I repeat it? It's basically what are the barriers for people to use the data that we collect in general. So I find that knowledge, distribution of the knowledge has been a barrier. Not a lot of people knows that we do this, and that is freely available. Even people within the academic community that have been working in oceanography for all their lives, they know that these data sets are available. I pretty much in every meeting from ocean sciences to Gordon conferences, etc., that I've been to, I meet some professor from a university that we start talking. I say, oh, we didn't really know that you guys collect that data and that is available publicly. So outreach is one of them, for sure. In terms of data accessibility, I believe that's a big thing, and I believe Philemon and GCOOS are working actively to make it simpler. I find that the easier that it is to collect it, to download a data set, the more people are going to use it. So if you don't have to be a computer whiz to write your own MATLAB or Python code to download a piece of data set, the more people are going to use it. So that's to me another barrier for the more casual user, or not even that, even for established people. So I think those two things are the main to me. There's more broad distribution of what we do and what we collected, and the length of the data sets that we have been collecting. So Marcus was saying that since 2005, I think is NTL, but we have data sets that are already available there that are being collected since 1999. So we already have like 30 years of current data allocation. So those who work with data series know that the value of long time series, and we have them there.
Can I add something? Yeah, I'll just add something here. Because I was just talking to Matthew from National Weather Service on my table earlier, and sometimes when I kind of explain, GCOOS to folks in my company, I sometimes compare that to like, hey, GCOOS is kind of similar to like a National Weather Service, but for the ocean, for the Gulf. But I think one of the differences is that because the National Weather Service, the weather forecasts, weather data that they're providing, it's basically it's affecting everybody. So that's everybody's checking their weather on their phone, so it's relevant to their daily life. But I think for a lot of the data we have in the Gulf, GCOOS is collecting, it's only relevant to kind of a specific community, right? Most people don't care about the wave heights or current speeds in the Gulf. So you're not gonna just kind of talk to a random person on the street and ask them, hey, do you know GCOOS or do you know anything about it? Yeah, you wouldn't expect them to have that knowledge. So, but I think within the community, like the operating companies in the Gulf, and also researchers that are active in the Gulf, GCOOS is very well known, and everybody knows GCOOS is providing such and such that is valuable to us. So yeah, so I think but I agree. I think we need to continue to do outreach and kind of make people more aware of the products that GCOOS is providing, and also, like Sergio said, kind of simplify the data access so that more and more people can use it without having to have some prior advanced computer knowledge to be able to do it.
I think Ben had
I comment a bit as well on stakeholder mapping, right? When you get 200 miles out in the middle of the Gulf, who are your stakeholders? They're largely the people who are also contributing the data, and GCOOS is largely a DMAC operation there. So mapping that as we get closer to the coast, the stakeholder density goes up exponentially with ports, fishers, and the like. The other folks I think about is like cruise ship operators. I bet they have no idea they're using GCOOS data, but their marine traffic routing system that tells them where to go is using all of GCOOS data. So when they sail out of New Orleans or Gulf, they just get a marine forecast of where they're supposed to go and what their most efficient route is. Whoever's providing that to them as a third party is then using the GCOOS data. So it becomes this sort of tiered level of access as well.
Yeah, can I add a comment here? Just from the money perspective, right? Just to set up the system as is, we have data from 2005 to yesterday, and so that's 20 years, right? There's roughly 50 rigs operating in the Gulf per year, right? Sergio just mentioned that if you were to start from scratch, you put a mooring and it's $1 million to $1.5 million per mooring. We're talking about $1 billion at least if you were to start this program from scratch right now.
Yeah.
So I mean that's a lot of value that just seems wrong that nobody's using, but the operators and us who provide the services to them, right? It's almost like a crime. But just floating that for you guys to know.
Chris?
In our IRA, TA top tier 1 funding, we did budget money for outreach for the NTL project. So to hear from you specifically, who needs to be at that table when we do that would be tremendously helpful.
And for you guys, it's easier because I've gotten questions from people that are mostly covered by the other regional associations. So people from California, PAC-IUs, that do not know what happened inside GCOOS, really, because they don't have it. So they assume that there's nothing going on.
Belmont, do you have a?
I will not make any comment on the utility of the data itself, but this is just to inform you guys that we are expanding the availability of the data. It is now available at NCEI. I'm sure the NCEI folks are here. So if you're having problems getting data from the GCOOS portal, the NCEI is also there to help you serve exactly the same data as you're getting in from GCOOS. Just to let you guys know that we have fully operationalized this already.
Pat, you had your hand raised.
Yeah, and to just expand on that a little bit, to the extent that you all use data that you get from NCEI or from GCOOS, the more we can provide concrete documentation of that, we're continually being asked to justify our existence through demonstration that we're providing, contributions to national resilience or to economic development. And so you using the data that we curate or collect or make available gives us, it gives us a lot of ammunition to justify our existence and say, yeah, we're really providing societal benefit or value to economic development or national resilience. So the more you can document those and make us aware of them, or you're using the data other than what you collect, the better for all of us.
Got it, Pat. Yeah.
Deborah?
Hi, Deborah Hernandez from SCORE. Really appreciate the conversation. My question is for Dr. Yang about your SKINS program and Deep Star. Is that, so we're doing some work with cameras, we're working with the other regional associations. I'm just curious, is the algorithm that goes from the picture to the current speed, is that proprietary or is that something that's publicly available?
So the short answer is the code, the IP for that system is proprietary.
Okay.
But the team that developed the system, they have published papers, conference papers like OTC, and there's a couple of papers out there that explain like the way how the system works pretty well. So it's not that difficult to just kind of read the paper, go through how they build it. It's not that difficult to kind of recreate the system based on the public information that's already out there. In terms of the skin system, like I said, it's one of a kind. It's literally one of a kind. There's only one unit. The reason being that it was a program under Deep Star. So after we built this unit and tested it, it was very good. We were happy with it. But then when we wanted to continue the program, kind of going to the next phase, the engineering company that kind of developed the system, they had some internal kind of realignment of priorities. So they decided to kind of stop supporting this program. So you kind of stop there. So after that, we have been kind of actively looking for options, like maybe other parties that are interested in kind of picking this up. Like I said, all the knowledge is out there in the public domain. So I would say, any competent engineering companies should be able to recreate the system. But that's where we are.
Jorge, you got a question?
I have a question about a project that Rafael is leading that is related to the NTL, but I'm not sure if it's better to talk about that now or after lunch.
So after lunch is going to be a segue. So if you have questions that you're unsure about, we can wait till later, or you can ask them now, and you might get answered later. We don't know.
So the question is, Rafael, I don't know if you want to share a little bit with the group the reanalysis project that you guys are leading.
Yeah, sure.
You want to go with the mic? So Dr. Ramos will be giving a presentation later for Woods Hole Group. So I don't know if you're going to talk about it, but this segues into the NTL reanalysis program that we're funding. So.
Yeah, talking about NTL data. As you might imagine, we just talked about 50 stations, right, that are independently maintained, have crews of people going, certain months and adhering to all the safety requirements on top of the rigs. So sometimes mistakes are committed, right? Like the instruments are mounted in the wrong way, or some of those systems, the positions are input manually and things like that. So there was a need for data curation of all that data set. So we started with that with Woods Hole Group since 2025. And we get all the data that is collected by Fugro, RPS, and us, and then we get to do a review more extensive than what you would get and the quality of the data itself. We do the review of the metadata. And so the data that is already displayed in Felimon's system is already curated. So you just download that and you can be sure that, you don't have, nine node currents, which is when the rig was moving and nobody notified that it was moving, like things like that. We take care of that. So we're doing that. We've done that. We started with the industry money. Then that data set was donated to GCOOS. And then we got some money to do some other years. And in its present life, GCOOS is funding us to do the curation for the next 4 years. So at the end of that program, the data would be all curated from 2005 all the way to 2029. That's where we stand.
Yeah.
Thank you, Rafael.
Thanks, Rafael. Anyone? Another question?
I do have another question for Sergio and or Mike. It's about the modeling that you guys do. Both of you in your presentations talked about you use the data for forecast and modeling. So are those models proprietary, or you guys also use what we use? And there's also a collaboration there.
So we at least, we don't do modeling. We don't do the modeling. So we pick up on both publicly available model, say HICOM, Copernicus, but also we have access to some proprietary model forecasting, like one produced by Woods Hole Group. We have also partnerships with the Naval Research Laboratory for a long-term forecasting of the loop current and loop current eddies. So in general, we use a third party to access that, because modeling is a pretty involving activity in and of itself, right? And none of them are right.
Yeah, no, exactly like Sergio said, all models are wrong. Some are useful, right? Yeah, so we pretty much use the same models, HICOM, Makeda, some of the public models, but also some proprietary models, and also the NRL long range model, which is, I think right now is probably the only operational current forecast model that will give us a forecast for, I think, 2 to 3 months. And it was run like in an ensemble fashion, so it's not running just one model. It's actually running like 30 different realizations of the models, so we can get like a pretty nice spread of different scenarios, and we were able to kind of develop some statistics of those ensemble members. And also another, I think previously, with somebody mentioned AI. So we were also kind of actively surveying the market, and also we actually evaluating some AI-based current forecasting models. So obviously, it's not based on physics. It's based on essentially using historical data, train the AI model, and then see if the AI can give us a forecast result that's potentially, on the same level as the physics-based model, even better. So we don't have an answer yet, but we're kind of looking at it. But even like with AI models, I'll say the the data from GCOOS is still very valuable, or even more valuable, because as you guys know, AI, in order for the AI models to work, you have to feed the data to the model to train it and test it. So whether we're using physics-based model or AI-based model, the value of the measured data is the same, or even more in the AI era. So I'll say that, AI is in the value that GCOOS is bringing to the modeling community, it's going to continue, even though, if there's any changes with kind of the way we do numerical models, or, the modeling strategies, but I think that the value of the data is still there.
Jim?
She was had her hand up for a long time.
You two want to duke it out, or?
No,
All right, Luce, go for it. And then Chip.
Thank you. Question for Dr. Yang. So NTL talks about collecting data, but there's nothing about data quality itself. From the operational perspective, what would move the needle on what GCOOS can offer to you, so that when you go to GCOOS, you can actually use that data and trust that data, right? Because what Rafael was talking about is a reanalysis of the data and cleaning that historical data, but for operational use, we care about the now and the future. Right now, when we have rigs and they move locations, we rely on a manual spreadsheet that we have to send. It's not like AIS driven. Like, what are the things that could actually move the needle so that your operational decisions can be actually supported using this database?
Let me answer something first.
Use AI.
I will say that the NTL data, the data that comes in, does go through the Quartot standard, quality control of real-time data, and that is implemented. So any of the data that you get from the GCOOS website, the data itself is quality controlled. Now, whether the metadata and the location is correct, that's something that we have a challenge in GCOOS to know, because again, we only know if it's moved when somebody tells us, right? So if
the GPS has been in the NTL for 5 or 6 years now. I know we're still following protocols of
Yes.
submitting sheets.
yes, and that's something that we can probably look into. But yes, Belmont.
I'll just make a quick comment about that. There are some companies, some of the data providers, they do really make effort to provide us with the current location of their models. I know that some of them do not, because they don't coincide with the GPS that is on the binary files. And what we do is we ping them and say, hey, is this correct? Say, oh, don't trust the GPS or trust the GPS. There are many answers to it. So we have to make sure that we follow a certain standard. So the data providers will have to tell us which one should we follow. It's just a little comment, but yeah, what Ben has brought up there is real. But we cannot change the data that is being given to us unless the data provider says so, that, hey, use the GPS, because the GPS apparently can also be manually configured or wrongly configured. So things like that. So just a little note on that.
And I think that's a good point, and that's where the reanalysis comes in, correct? Where they start actually they take this data, they know the timestamp it was, and he's going back and says, nope, that's not where it was. Let's fix the metadata to where it's actually correct. So that's where the reanalysis comes in. So there is a grain of salt in there, right? The data quality itself is good, but the actual location could be in question, right? So good.
And also just kind of add to that is, we don't use the measurement data blindly. Like, for example, when we do operational support for, the Gulf of America, when we see, basically we look at different stations, right? So if all of the stations, all the other data sets were indicating, hey, this particular asset is inside the 80 front, but then you have like one outlier station that says the current is less than 1 knot. Obviously, something's wrong. So we have this very old-fashioned kind of human eye QA, QC in the process usually.
This one was.
All right, Jim.
Yeah, Jim Kendall on the board. I'm not sure if this is a question, a comment, or something to think about, but both presentations were excellent. Now, Sergio, you mentioned that the NTL requires measurements down to 1,000 meters.
Yes.
and it would be good to go deeper.
Yes.
You also made the comment about in very deep water with pipelines, there's not a lot of information.
Mhm.
With the thousands of miles of pipeline on the seafloor, and they don't stay where you put them, they move. It's been described as spaghetti. Would deep water instruments that are compiled help us respond better if something bad were to happen in deep water, to not only find those pipelines, but also respond to them?
Yes.
Okay. A lot of folks don't know that the pipelines out there, they're not where they move.
Yes.
And
No,
I think
it's-
it's close to 20,000 miles of pipelines or something like that.
I don't know how many there are, but if you see one of the GIS maps, it's like the veins on your body. I mean, they're everywhere. So yes, absolutely. Near bed currents are, so the two biggest gaps in terms of measurements that we have are what Mike Yang mentioned, the upper 20 meters of the water column and the bottom. The bottom is by far the least one, the least sampled of them all. And here in the Gulf, we have very particular phenomena that occur near the seabed. Not only near shore, which are very, very important for the pipelines, but also deep offshore along the 6B escarpment, where we know we have elevated currents that we don't fully understand yet. But it's problematic because you want to get also real-time measurements, not only self-contained measurements. I mean, I take self-contained measurements over no measurements for sure, but ideally it would be presented in real time. But that is a technological significant challenge that there is.
Thank you. Just wanted to bring that to the table for people to think about. So thank you.
We'll do one more question. Go ahead, Ben.
Yeah, an infamous story from about 2018 where I went to the ATP offices and I had to explain to the superintendent there that he only had measurements from 30 meters to 1,000 meters because that he'd only asked for the NTL spec. And he said, "God damn, that's like having season tickets and never getting the playoffs." From that, would you advocate sitting in the operator's seat for a larger scope in the NTL to include surface measurements? We've Teledyne RDI has stopped making their horizontal ADCP, which we used to use to measure surface currents, because there wasn't enough demand. From a data perspective, we always want it, but does anyone want to be mandated, and what could GCOOS, IUS, and the wider advocacy in this room do to push that in the direction you'd like to see?
Well, I can tell you this from the Sergio Jaramillo perspective. Because it's very hard for me to tell the overarching shell or oil and gas industry what should be required or not. In my role as a methodology engineer would make my life easier. For sure. But it is difficult and it's very challenging and it costs a lot of money to fill those gaps, especially in areas where are perceived as nothing happens. We have areas of the Gulf where the currents are really, really mild down there. Same at the surface. So it is not a simple answer. I think it's on a case-by-case basis for sure. There's NTL guidelines for when you are operating near the 6B escarpment. So that part is covered pretty much. NTL also only covers 400 feet and deeper. So we have a lot of other platforms, 400 deep and shallower, that have absolutely nothing on them. So as we move on these pipelines that were designed 30, 40 years ago, probably over-designed because they have withstood the test of many, many hurricanes, as we move on to develop new ones, we have not that. So we either over-engineer or try to sharpen our pencils in some way or another without data. So we do need the data.
or managed the leak at NC50 for the last 10 years.
So I'm gonna go ahead and stop this session here. So I'll give a thank you to Sergio and Mike. So appreciate it. So I'm not gonna conclude this session yet until our picture is taken, so nobody gets to move. So sorry. You can go ahead and stop. Okay. Guys online, we'll be back around 1 Central Time, so we're gonna go ahead and stop the recording and transmission now. So thank you.